Assalamu alaikum. Welcome to lecture number 31 for the subject of software design and architecture. iTech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, if you remember what we discussed in our last lecture we actually discussed the reusability approach of a software reusability approach like software product line, where we see how architecture for product lines actually captures the architectures of many related products simultaneously. And then we see how a product line architect needs to consider three different things like identification and identifying variation points, their supporting variation points, and then the evaluating the particular architecture for that product line suitability as well. And then we see the different approaches of software product line, where we see a proactive product line, reactive product line, and the extractive product line. In the proactive product line approach, where we see how it actually based on the SDLC work, where we extract the different assets, and now from these assets we actually develop a product. And then in the reactive product line approach, we see it actually bases on the spiral type model, from where we actually extract its assets and from where we actually build over the final products. And then we see the extractive product line approach, which actually based on the existing software products, from where we extract different assets, and now based on these extracted assets we actually build different product lines. And now from these product lines their corresponding baselines are developed, and now these multiple baselines are utilized to achieve a final product for any organizations. And then we see some benefits of software product line, and we also see the challenges of software product line, and we see how product line actually provides a way of formalizing the manner in which these applications are actually managed in any organizations. And we see the goal of a product line actually is to maximize the benefits which can come from managing group of applications together. And conclude and at the end of our software product line approach, we say reuse in a product line is a byproduct of the structure of the organization. So it reduces development, quality assurance, and maintenance cost, and getting products time to market faster are the real benefits of product line approach. So students, it's our discussion of our last week. Now in this week we will discuss the second reusability approach, which is actually about the model driven engineering. So students, let's formally start the our today's lecture discussion. So here is a brief objective of our today's lecture discussion. In this lecture our focus will be on another reusability approach in software engineering, which is named as model driven architecture or model driven engineering. So in last week we see the software product line reusability approach, and now in this week our focus will be on model driven architecture reusability approach. So here is a brief objective of our today's lecture discussion. We will discuss different software reuse landscape in a nutshell, and then we will see what is actually model driven engineering, and we see the different usage of model driven engineering around our daily life. And we will also focus on their pros and cons as well. And we will see how OMG group achieve the milestones of MDA model driven architecture, and we will see some basic concepts about model driven architecture. So student, this is a objective of our today's lecture discussion. So students, here is a software reuse landscape. So all of these are software reuse approaches. So these are the different software reuse approaches which we actually utilizes in our software design and architecture, and in our daily life as well. So students, in our last lecture we discussed the software product line approach, and now we already have been discussed in our last week as well. And now in this week our focus will be on model driven engineering. So all of these are software reuse approaches. So about these software reuse approaches, like our students over the past 20 years, like many techniques have been developed to support software reuse. So students, basically these techniques actually exploit the facts that the system in the same application domain are similar and have potential for reuse as well. So that reuse actually is possible at different levels, from like simple function to complete function, and and that standards for reusable components facilitate reuse, etc. So in this figure, there are a number of possible ways of implementing the software reuse, and all of these are the different reusability approaches. So in this reuse landscape, the key question is actually what is the most appropriate technique to use in a particular situation. So students, obviously the answer is it actually depends on the requirement for the system being developed, and the technology and reusable assets available, and the experts of the development team as well. So these are the different factors. So along these factors, so there are some key factors as well that should be considered when planning to adopt any of these reusability approaches. So what can be with the factor, like we can say the factor number one can be the development schedule for the software. The other factor can be the expected lifetime of the software which we are going to build. Another factor can be a background skills and experience of the development team will be another important factor, and the criticality of software and its non-functional requirement is also another aspect as well, and its application domain as well is also an important point while we are going to choose uh, the most appropriate reusability approach. And at the end, the most important, the platform on which the actual system will be run. So students, these are the different factors which actually plays a most important role while we are going to choose the software reusability approach. So these are the some factors on which these software reusability approaches are actually depending. And now in our previous week, our focus is was on software product line, and now in this week our focus will be on model driven engineering, and in next week we will discuss about the aspect oriented software development as well. So students, let's formally start the model driven engineering, which is an important aspect of software reuse. So what is actually a model driven engineering? So students, model driven engineering is basically an approach to software development, so where models rather than programs are principal output of the development process. So the program which that execute on a, you can say, on a hardware or software platform are then generated automatically from these models. So basically model driven engineering actually argues that this raises the level of abstraction in software engineering, so that engineer no longer have to be concerned with programming languages details or the specification of execution platforms as well. So this model driven engineering has its root in model driven architecture. So this model driven engineering or model driven architecture was actually proposed by the OMG, stands for Object Management Group, in 2001 as a new software development paradigm. So this model driven engineering and model driven architectures are often sees as the same thing as well. So this however students, I think that this model driven engineering has a wider scope than a model driven architecture. So model driven architecture actually focus on the design and implementation stages of software development, while if we see on the other hand, model driven engineering is actually concerned with all aspects of the software engineering process. Therefore topics such as model based requirements, requirement engineering, software processes, process for model based development, and model based testing are part of model driven engineering, but not the part of model driven architecture. So we can say that model driven architecture has a more narrow scope, and the model driven engineering has a more wider scope across the entire software development life cycle. So model driven engineering is still an early stage of development line, like, and and it is unclear what or not it will have a significant effect on software engineering practices or not. So it's a still an open research issue as well. So there are different advantages and disadvantages of these model driven approaches as well. So this model driven engineering actually allows the system to be considered at a higher level of abstraction. So this what does it mean? So this model driven engineering actually raises the level of abstraction in software engineering, so that engineers no longer have to be concerned with programming languages details or the specific of execution platforms. And another benefit of this approach is, as generating code automatically means that it is cheaper to adopt system to new platforms as well. So these are the advantages of this approach as well. And on the other hand, models for abstraction and not necessarily right for implementation is a major drawback of this model driven approach as well. And like saving from generating code may be outweighed by the cost of developing translation for new platform is also a major drawback of this model driven engineering. So students, in a nutshell, we can say that model driven engineering is we can say about this model driven engineering is basically an approach to software development in which a system is actually represented as a set of models that can be automatically transformed to executable code. So that's why this MDE actually raises the level of abstraction in software engineering. So that is the only reason software engineers then not longer have to be concerned about what kind of programming language details or the specific execution platform as well. So this is about the model driven engineering. So this is the about the how model driven architecture from this approach is actually developed. So students, you need to note one thing about this model driven engineering and model driven architecture are basically the two same things. Model driven engineering like has its root in model driven architecture, and it was actually developed by the OMG group, which is an acronym for Object Management Group, in 2001 as a new software development paradigm. So this model driven engineering and model driven architecture are often as the same things, but as I discussed in the previous slide, model driven engineering has a wider scope across the software development life cycle, from requirement engineering to development to implementation to testing as well, while the model driven architecture has a more narrow scope only on the design level as well. So here is a brief history about how MDAs actually evolved. So in 1989, this object management group was actually formed, and then in the 1991 we get the Corba, and then 96 we get another version for 2.0 of Corba, and then we will develop this unified model language, and then ultimately in the 2001 we comes at this OMG group actually comes and at an point to get a model driven architecture. So what is this OMG group? Student, basically this OMG is an object management group, which is actually is an international or open membership and also a non-profit technology standard consortium, which is actually founded in 1989. And these OMG standards are actually driven by students, different vendors like end users, academic institutions, and government agencies as well. So these OMG task forces actually develop different enterprise integration standards for a range of available technologies and even wide range of industries as well. So these UML and MDA actually enables powerful visual design and execution and maintenance of software and other processes as well. UML and the MDA basically the two most powerful visual designs approaches which are actually provided by this object management group. So what is an model driven architecture? So students, this model driven architecture is basically developed in 2003 and 2004 respectively. So basically this model driven architecture is a model focused approach to software design and implementation that actually uses a subset of UML models to describe a system. So so students, here actually models at different levels of abstractions are actually created. We will also discuss its model, graphical overview in later slide as well. So from this model driven architecture, which is actually the ancestor or a precursor of more general model driven engineering. As I discussed earlier, model driven engineering and model driven architecture are the same thing, but this model driven engineering has a wider scope than model driven architecture, because the reason is model driven architecture only focus on the design and implementation stages of software development. Like students, on the other hand, if you see, this model driven engineering is actually concerned with all aspects of the software engineering processes, like which include the requirement engineering, the process model with development, testing and maintenance as well. So we can say that model driven engineering has a more wider scope across the software development life cycle, and but this model driven architecture has more narrow scope as compared to model driven engineering. But this model driven architecture will only focuses on the design and implementation stages of software development. So this model driven architecture is actually has a significant important across the top notch companies in the world as well. So students, these models at different levels of abstractions are actually created from a high level platform independent model. Actually, it is possible in principle to generate a working program without manual intervention. So there have been significant success stories reported by the object management group on their web page. You can just go there in their product success stories, and the approach is used within large companies. Who utilizes this approach are the well-known companies like IBM and Siemens, are the top two notch world companies who are on the success list of this OMG group, who actually utilizes this model driven architecture. Actually, this technique have been used successfully in the development of large long lifetime software systems such as air traffic management systems. So students, in this type of situation, this model driven architecture is normally utilized. So about this model driven architecture is basically a software design, which is an approach for development of software system which is only focuses about the design and implementation stages of software development. And this model driven architecture, students, actually it provides a guidelines for the structure of specifications which actually expressed through different models. So this model driven architecture is basically a development and implementation approach. As you can see, its name suggests this approach uses a model as a set of guidelines as we use in the structured design specifications as well. So this model driven architecture is a type of domain engineering, and it only supports the model driven engineering of software systems. So students, this model driven architecture basically a model which actually only focusing on the approach to software design and implementation, which actually further uses a subset of UML models to describe a system. So this is about how actually a model driven architecture. So basic concepts behind what is a model. So model is basically a formal specification about the functions like structure or its behavior. So it's a proper definition of model. So source code actually is a model, and the UML based specification is also a model. So these are the two examples of model. So I don't need to recall the concepts of UML over here, because UML module of our discussion is already have been discussed in our for lecture number 5, 6 and 7 as well. And I don't need to discuss these UML based terms again and again in our coming lectures as well. So source code is also a type of model, and this UML based specification is also one kind of model. So further, these models actually have of different systems are structured into two different models. Number one is PIM, stands for platform independent model, and the second one is platform specific model. So students, now what are these two types of model? These two models are actually utilizes by this so model driven architecture. This platform independent model is actually a formal specification of the structure and functions of a system that abstracts away technical detail about the system, like expressed using this platform independent model is actually expressed with the help of unified modeling language. And the second important model is platform specific model, and this platform specific model actually specifies how the functionality is specified in a platform independent model and realized on a particular platform as well. So students, you need to note this important point here. All model driven architecture projects start with the creation of a platform independent model, and this platform independent model at this level actually represents a business functionality behavior which is actually understood by the technological details as well. And after the creation of platform independent module, so once the first iteration is complete, the next model is platform specific model. So the platform independent model is actually serves as an input to the mapping step, which will produce a platform specific model. So we can say that coding is partially automatic and partially handwritten in this approach. So platform independent model can be mapped either to a single platform or a multiple platform as well. So students, here is a discussion of about our today's lecture number 31. We will see about these two functions and model transformations in our later lecture as well. So students, still here our lecture number 31 is ended.